Alrighty. Hi, everybody. Today I'm going to share a little bit of research that I've been working on. It's remote access tools. Been doing this on and off for about the last 2 years, but found it to be a pretty good stopping point to write up a bit of information that might help you use the behavioral types of techniques that I'm going to talk about in your day-to-day hunting type of scenarios. So first thing we'll talk about is why care about rats? Well, they happen to be all over the place these days. Uh, a number of major breaches have occurred that have leveraged remote access tools. The APTs use them all the way down to people who simply download scripts and go to town on whatever they can. So it's a pretty versatile tool. There are a number out there. In fact, I've looked at about a half a dozen, but I know there are many dozen, if not hundreds, that exist. And so being able to look at each one of those and understand it in depth just isn't possible. So you need to find a different way. And if you think about it, I've done some research here. You find some really interesting things that rats leak. So in this example, the top two screenshots here are TeamViewer, which is a very popular, legitimate remote access tool. And so on the left side, we see my MAC address and my OS being leaked out across the network. So this is in the clear, lightly obfuscated. This is using a script that I extended that somebody else had started. But that information gets leaked, and so you can really track somebody that way. On the right here, we see, again, TeamViewer, and in this case, it's leaking both my public and private IP addresses and the ports associated with those. So not only would you know what public-facing IP somebody's using, you would also be able to figure out what IP address they're using behind, if, for example, if they're behind a NAT. So really, things that don't need to be sent across the network, they don't have a purpose, really just odd to see. And this bottom example here is, this was TLS traffic, and I would be doing air quotes here because clearly you can see in the payload here that it's more or less an HTTP request in the clear. It's just tunneled inside of a TLS payload. So some really weird things happen. And that's not TeamViewer, that's a different one. So as I alluded to earlier, there are a lot of remote access tools. And the status quo is to detect them as an enterprise, discover the things that you care about. So find the remote access tools that are used in your environment and look at figure out how they're used and so on, identify their indicators, etc. Take action. So capture all of that information in whatever security tool or tools you use. And then it's more or less a hope game. Hope that they don't do any changes to the infrastructure that would change your indicators. Hope that there aren't any new rats that become important, etc. Not so great, right? Does it remind you of anything? So it reminds me of whack-a-mole, and it's pretty problematic, again, as there are dozens, if not hundreds, of different remote access tools that are important. So I have a better way forward. So instead of thinking about what remote access tools you want to care about, think about the things that you care about remote access tools doing. So if you think about what you wouldn't want an adversary to do on your network, you certainly wouldn't want them to take remote control of a system, right? They essentially have keys to the kingdom, can do whatever, can pivot from there, etc. That's very much the worst case scenario. But not far below that is the ability to upload or download files. This could be exfiltration. This could be pulling a stage 2 download to the system to escalate privileges or to pivot from there, etc. So still a big problem. Of course, there's also remote view, which would be just passively watching whatever somebody is doing on a system. So that might be watching a user click on files, watching a user browse, etc. Not great, but definitely not as bad as the other ones. And remote audio, you could imagine somebody listening in on a meeting, which could be very bad, but on the average isn't as bad as having somebody completely inside your network with full access. So I also want to point out that there is threat research that exists. Unfortunately, there's not as much as I'd like. And so I've been helping to contribute to this, to improving this. I have a couple of different blog posts that are a few different blog posts up here. The first one, it was written by a guy named Braden Thomas almost 6 years ago at this point. And that was the first threat research that I had found, talking about in-depth details about different remote access tools. I found that while I was working on my TeamViewer research, which is what the second blog post there, the title is about. And then finally, I did another one on LogMeIn. And I have a handful of other ones too, but I've never completed them and fully published them. But if they'd be helpful to people, please don't hesitate to reach out and ask me to get those written up. And I know that there are more resources out there, but they may not be as fleshed out as these three examples, but definitely leverage things that exist. So going back to the behaviors that we were talking about, they're very important things that you need to look for that are associated with those behaviors. So the way I think about them are, we have these different capabilities that we talked about, and then we have behaviors associated with pretty much every layer of the, if you will, the TCP/IP stack, just as a way to frame your thinking about them. So we have everything from an application level behavior, which might be long-lived sessions, for example, something that you would expect a remote access tool kind of a program to do, and peer-to-peer. In the research that I've done, this is where leveraging threat research that exists is helpful. In the research that I've done, looking at the traffic associated with things, I very often see as quickly as possible the remote access tool going to a peer-to-peer type of communication because it doesn't want to leverage the infrastructure associated with whatever remote access tool it's from, right? You wouldn't expect TeamViewer to want to support all of the communications directly through their servers. They want to get things off of their servers as quickly as they can so that they spend less money on infrastructure. And then connection behaviors. So a step down, you're thinking about individual connections within the traffic associated with some remote access tool. So you could have different size packets, right? You could have large or small. And it's, what's the most common thing, right? And of course you can have high or low or even packet ratios in terms of sent to receive. And so that can indicate other things. From a protocol level, if you're thinking about layer 4 in this case, we have TCP or UDP essentially. And kind of going back to what we saw with the examples where data was being leaked, you might have tunneled data going over one of these transport layer protocols, right? So we see that a fair bit as well. And then finally, if you think about a layer 3 kind of scenario, destination behaviors, right? So what distinguishes the behaviors that you're interested in from maybe corporate approved behaviors with the same remote access tools. You most likely wouldn't expect users to be communicating with virtual private servers or home IP addresses or Tor, for example. And so now we go back to the capabilities that we talked about in order of how severe it would be if an adversary were able to accomplish it. And let's actually see, again, this is what I've come up with that more or less captures the general case for these scenarios. There are cases where it doesn't always work out. And in fact, the next step that we have planned for this is to actually build some models that can detect this stuff in a machine learning kind of perspective, rather than a human going through hundreds and hundreds, if not thousands, of samples and manually classifying them. So this is more of a way to start to point out there are some patterns that you can start to follow, but don't take this to mean that this is the only possible way that something can be achieved. So again, remote control is the first thing that we'll look at. And if you think about it, so I want to point out the application behaviors column and the destination behaviors column. They will both more or less match all of these things because they are what you would expect for an application, regardless of whatever the thing is. The connection and protocol behaviors are the ones that change the most. So in this case, remote control, it's a bit difficult. You might expect that the connection might be more of an interactive kind of thing. So you might expect an even ratio of packets sent to received. So I don't explicitly call that out here, but that would be one way that you would identify remote control kind of behavior, because the adversary is interacting with the device, and so data is flowing to the device to tell it to do something, and then of course video is coming back to show that something's happening. From the protocol behaviors, very often you see this going to UDP as soon as possible, mostly for the perspective of, when you're doing video related things, you want as low latency as possible, and so UDP provides that. It doesn't matter if every single byte is delivered in order or something like that. So you don't need to worry about the connection and how perfect it is. Now files, on the other hand, if you're doing an upload, you would expect that the average packet size will be larger, right? You're uploading data. And so you would also expect that you're sending more data than you're receiving. So that's kind of all makes sense. And because, again, these are files, you would expect that they do need to be perfect, if you will. And so you expect TCP to be the transport protocol. Same with download, just happens to be that the packet ratio sent to received is reversed. We have a low sent to received ratio. When we're talking about remote viewing, so just looking passively at somebody's screen, again, there's not really any particular connection behavior. You're not necessarily interacting with it, but it depends on how much change is happening, because these things are smart and they don't send back every bit. They want to compress as much as possible, and so you may not get as much data as you expect. From the protocol, though, again, because this is a video perspective, you want to be low latency and you don't care if it's perfect. So UDP is what we see. And same with audio as with video, except for in this case, the audio is very often just small blips of data of somebody talking or of a noise happening. And so you expect that the average packet size is actually small. So why do we want to do behavior-based? So this table that I have up here, these are traditional techniques. These are the whack-a-mole styles, right? So if you identify a domain associated with some remote access tool, it's probably only relative to that remote access tool. So if an attacker changes a remote access tool, that's a problem. They can simply just register a new domain, etc. Right? So it's very easy for an adversary to avoid detection or to move on. Same idea with an IP or a range of IPs. They can use a new provider. They can do whatever they want. It's not that hard to avoid. And then string match. Well, for starters, string matches aren't very good. They don't well identify things. You have lots of false positives, and so that's the first problem. But it's really not that hard to change a string, especially if it's something that's sent in the protocol. Very, very easy to change. But from a behavioral side of things, if you're identifying file upload or download behavior, the adversary, in order to evade that, has to rewrite the file transfer mechanism, which isn't something that they're likely to do. If they are, then there are other things that we need to worry about beyond just being able to detect them via this behavioral capability. And of course, long-lived session behavior, again, the way they would avoid that is to rewrite the communication mechanism, which again isn't something that's easy to do. So it affords you a lot better coverage in terms of the number of remote access tools that you can look at the same time. And it also provides you with a harder thing for an adversary to change. So I've actually done some analysis of traffic with our tool, with the Awake system. And so you can express pretty much all of the things that I've talked about and more in our query language. And so you can literally search your data for this as you go. And you can write things that will automatically detect these behaviors as well. And so some of the things that I found once I see what has come back, and then I do a bit of analysis on it to make sure that it is what it is, I found RDP across both TCP and UDP. So again, I'm looking across different transport layer protocols even, and I'm still able to find this stuff. Same with TeamViewer. And I should also note that we aren't, in the case of TeamViewer, we do have a protocol parser that parses TeamViewer, but what I'm talking about here is just looking at TCP and UDP behaviors. I'm not actually leveraging an application level protocol parser like something that recognizes RDP. I don't need to. I can just do this from behaviors with our system. WebEx, I've been able to find that via UDP. The next one's interesting. We have a lab infrastructure set up internally, and we have SSH tunneling set up to interact with it remotely, because our team is both local and remote to the office. And so when I first ran some of these behavioral queries, got a handful of these sessions back, and I cross-validated with some of our team and found out that, yeah, in fact, I was detecting people working on working with VMs remotely just by identifying this behavior associated with accessing our lab over SSH tunnel. It was kind of a really cool thing. And then, of course, this one, I didn't even realize that I would be able to detect this explicitly at first, but WinSCP, which in some respects is definitely a remote access tool, but definitely a little bit different. There's not a visual aspect of it, but I was able to identify the file transfer associations with WinSCP over TCP by using my behavioral-based queries. So some really interesting things, and this is just a high-level overview. I haven't talked about any details here, but yeah, there's lots of really cool things that you can do here. And I also wanted to not only show you some of the things, but I wanted to explain ways that you can extend and improve what we see here. So if you want to go and dig into the weeds of a new remote access tool, or you want to validate the work that I've published, I'm sure everybody who's listening to this is familiar with Wireshark. It's very good for in-depth analysis. That's pretty much the go-to. But you might not be familiar with this tool called CyberChef. It's essentially a Swiss Army knife for SOC analysts and hunters. It's a really, really cool tool. If you just Google CyberChef, I think it's created by GCHQ. It's just a fantastic tool. So check that out for rapid prototyping. And then once you find the thing that you want to do, the rapid prototype that you're ready to do, then you can turn it into a reusable parser that you can leverage Wireshark for via Lua. And so the Wireshark parser that I extended is based in Lua. And yeah, it's a programming language. It's not too bad. And I also wanted to point out here are some other things that that are helpful. The TeamViewer and LogMin blog posts that I've created, you can access them by clicking on the links here. I also, in 2018 in the summer, I created a workshop and presented a workshop at DEF CON on protocol analysis via reverse engineering the network traffic. And so the entire workshop was focused on examples associated with TeamViewer. And so if you want to really get in the weeds really deep, it was a 4-hour class and it could have easily been 8 hours. That's a great opportunity for you to really understand the methods behind what I'm doing. And of course, as I mentioned earlier, the TeamViewer blog series that I had found later in my research by Braden Thomas, who was formerly at Optiv, is another great resource. So just high-level takeaways that are helpful. Today, we don't do a very good job with identifying remote access tools, definitely not in a generalizable way. But if you use behavior-based detection, it's a lot harder to evade that, and you can get a lot more bang for your buck, if you will. And whenever possible, leverage others' research. And if you do research, please do share as much as you possibly can, so that everybody in the community benefits. Right? We just want to do better as a community. So with that, I'll leave it open for questions. I know this isn't a live session, so if you do have questions from this, please do reach out to me. You can reach me LinkedIn, or the Awake blog, Twitter, my email, etc. Please, I look forward to talking to any of you. All right, thanks.